6/9 now. Didn't make any mistakes there, did we? Hey folks, welcome, and welcome again. And we'll welcome you one more time to Tea and Learn Mathline Summer School. Get laid back, let's have a good time this afternoon. Thank you for tuning in. I am Ernie Roberts. I am your host for this afternoon's session of Tea and Learn Mathline Summer School. Now, for those of you who've been tuning in during the summer, we appreciate you. Those you haven't, hopefully you're in for a treat. We think we got a great show planned for you, but it's a little bit different than what we do during the regular year. We don't have a call in today, but you can take notes, get some pencil and paper out, draw figures with us, play the algebra, do all sorts of fun things. I think they're fun anyway. Yeah, don't you? And sit back, relax, let's do some math, and let's see what we're going to be talking about today. What's our topic? Angles. Let's see if I can try that again. A. All angles are relative. All angles are relative. Now that has quite a lot of wide open meaning to it, all right? But we're going back to the parallelograms today, and we're going to look at the angles within those parallelograms and see how they affect and work with each other. So it is all relative because what happens with one influences everyone else in the parallelogram. So let's take a look at a picture of a great looking parallelogram and see what we're going to do with it, all right? It says, what appears to be the relationship between each pair of the opposite angles of a parallelogram? Now we've got a nice pretty parallelogram here, all right, all filled in pretty. And notice again, I like for us to just review, how do we name a parallelogram? Well, we pick one of the letters. It doesn't matter which it is to start, but once we do that, we move clockwise or counterclockwise, all right? So let's take E, all right? We'll start with the letter E, alphabetically. I know, yeah. And what we want to do, we want to put a nice little symbol for that. There's a symbol for parallelograms. That's what we're going to see throughout this lesson, and also in your textbooks and your worksheets and all those great things you get when you go back to school, all right? But anyway, we're going to start with E. Now, I could choose to go E, H, G, F. That's one option. But I'm going to just go ahead, not because it's alphabetical, but just because it's kind of my flow. I'm going to go E, F, G, H. Notice I just worked myself around the figure. It's a clockwise or a counterclockwise move here. So let's pick it up. We'll say E, F, G, H. And that tells me a lot of things. It tells me when I look at E and G that those angles, those points, those vertices are opposite of each other. So I'm looking at angle E and G as being, what are we looking for today? Opposite angles. And the other part I'm going to be noticing is that F and G also work. Now if I get those out of order, it's not going to match up. All right, it's not going to match up. So we got to name our parallelogram correctly. Then we will talk about what's opposite in terms of the angles. Now, we've already covered a lot of facts about this parallelogram. Let's just go over them. First of all, opposite sides, you see them, segment EF, HG is one pair of them. They're parallel. They're also congruent. In a previous lesson, we got that established, all right? Now, on EH, that's an H, by the way. Some of you are going like, is that an H, George? Yeah, it is. There it is. And FG are also opposite sides. They are congruent, and they're also running parallel to each other. That's the beauty of being a parallelogram. If you aren't a parallelogram, none of these properties, none of these theorems, none of these rules apply, all right? It's otherwise a quadrilateral and you're just wide open, all right? And there's no specifics. So you've got to have that parallelogram quality and requirement, all right? And that's what we have here. And that's what we've got. Nice, pretty parallelogram. So again, parallels, two pairs of them. Opposite sides are also congruent. So let's talk about opposite angles. Let's look at angle E and angle G. And what are we going to put in between there? All right? I think most of you are probably looking at E and G and saying, they are congruent. They look congruent. Are they congruent? Remember when we drew a diagonal back on a previous show? I'm not going to go back through it again, but we drew in the diagonal HF here, and we created two congruent triangles, all right? Two congruent triangles, which allowed E and G, yes, to be congruent. So these, I don't know if that'll mark up. I hope it does. These two are congruent down there, all right? Put two ticks on them, and that helps me out. You say, well, Ernie, does that mean H and F are going to be the same thing? Well, it looks that way. And again, if I drew my diagonal this way, I would also have two congruent triangles. and F and G would also match up. So yes, we can go right on and say that angle F, angle G are also congruent. Now, let's see, what is that telling us? What's that telling us? What appears to be the relationship between each pair? They seem to be congruent, and they actually are. We can prove them. As I said, we can prove by using the triangles. When we draw a diagonal in there, they are congruent, and they have it called CPCTC. Those you're wondering, what's he talking about? Corresponding parts of congruent triangles are congruent. C, corresponding. P, parts. Congruent, C again. T, triangles. C, congruent. So we have two different words that apply to the C's, but we call it CPCTC for short. Again, corresponding parts, congruent triangles are congruent. And that's really what we're doing here. That's what allows this to happen. If we don't have a parallelogram, folks, we don't get anything. And again, all those things that we don't get opposite sides being congruent or parallel. We don't have opposite angles that are going to match up congruent. And by the way, it's opposite angles. There's a pair. There's another pair. That's what we're going to focus on today, is working with the relationship. Now you say, what about those other options? What do you call them? Consecutive. Well, I'm glad you asked. Let's think about that. Let's see what we got going on that, all right? Let's see if we can find some examples on that. Thinking about them, consecutive. Hey, here's another parallelogram. What can I say? Let's go with it and see what we've got. Here is A and there is D. Obviously, one is obtuse, one is acute. Duh, you got that right. But let's go a little bit further. We also have consecutive angles with A and, finish that B out there a little bit. There we go. A and B, they're also consecutive angles. They're in pairs, right? Let's go with D and C. Oh my goodness, consecutive. And finish the cycle while we're at it. B and C. So we got 4 pairs of consecutive angles in this picture. Oh my goodness. So let's start off with what looks pretty easy to me, A and D. All right, let's start off with angle A. What do you think? It's a what? It's a parallelogram, right? Some of y'all love that silence. You're going, is he waiting for me to answer? Of course I am. Gives you a chance. Think it, talk to yourself a little bit, all right? Now, remember, it's a parallelogram, so we have parallels going through here. We got parallels. Now, if I were to extend, and I'm going to, these segments out as lines, you're starting to see where I'm going, don't you? You can do it back here. Here you go. Oh, create some transversals. We got them going here, guys and ladies. Oh, yeah. There you go. See how this is working? Oh, and by the way, these are running parallel in case you're thinking he's going to leave something out. Wow. But what happens is I all of a sudden have each side can become a transversal. Now, if I were to cover up everything over here for just a little bit, just kind of put your hand over your tail. You can't put your hand over the TV screen. It's too big, right? But let's see how this works. Ooh, with parallel lines, we've got a relationship between this angle and this angle since the lines are parallel. Now, I'm going to put 2 ticks here and 1 tick there because obviously angle D is a much larger angle. Folks, they're inside the parallel lines, which makes them interior angles, all right? That's the first thing we want to think about. They're also on the same side of this sweet little transversal, AD. AD. So guess what? You know what I'm guessing? There are same side interior angles, we call it. Sometimes we call them consecutive interior angles with the parallel lines. So you're like, I'm having to think a minute. What was the rule? Back when we did parallel lines a long time ago, and probably when you did at school a long time ago, you basically had 2 options with the angles. They were either going to be congruent or supplementary. So, Ernie, what's supplementary? That's a nice word. It means they add up to 180 degrees. Add up to 180 degrees. So the supplementary angles, that is the ruling. That's what we're going to look for. So if you'll drop my bottom third out there, guys, let me write that up here. We're going to say consecutive angles. Let's see if I can spell, ladies and gentlemen, consecutive angles of a parallelogram. They're not congruent, are they? N-O. They are supplementary. So that tells me something about A. I put it up here. I said, but it's all relative. Remember, we said earlier that A and C were going to be congruent because they're opposite angles. We said B and D were going to be congruent because they're opposite angles. But dear friends, A and D certainly are not congruent, all right? And so here's the deal. Since we are going to say consecutive angles of parallelogram are supplementary, the measure of A plus the measure up there of D adds up to 180 degrees. That's your story. Now, Ernie, yes, you say out there. I said, you know, Ernie, there are more than one pair of consecutive angles, correct? Exactly. There are 4 pairs. And guess what? They're all going to be supplementary to each other if you look at them as a pair of consecutive angles, all right? So we want to keep them in order. Let's go ahead and pick up D. If we add it up to angle C, yes, we get 180 degrees. You get the idea. We're going to do a quick review right here, aren't we? And come on down this side. Yes, we got parallels running everywhere. That's the beauty of a parallelogram. You can get parallels going this way. You can get them going this way. Does that just twist your mind out there right now? Yes, sir, it should. Summer school, right? So let's finish it off here. How about B plus C? We also come up with 180 degrees. And while we're at it, finish it off. A and B. Yes, 180 degrees. All those are supplementary pairs. That's cool because basically, remember with parallel lines, everything pretty much came out to be congruent or supplementary when you were comparing angles between the lines or around the lines with the transversal coming through. Same thing's holding through here with a parallelogram. Our angles inside are either going to be congruent or supplementary. So let's practice a little bit. Okay, let's do a little bit of practice with this. I like practice. Y'all go, oh, practice, right. Yeah, let's take a look at it. See what you've got here on this next one. It says, find the measures of the other 3 angles of the parallelogram if one angle measures 65 degrees, all right? Not even going to worry about putting letters on these. Well, yeah, let's do that. Sometimes that helps us get directed a little better, right? So let's have it K, L, M, and N. Just work it around there. It is a parallelogram. That is given to us, all right? And again, if you pick one of these letters, just make sure you go in clockwise from there or counterclockwise to name your parallelogram, all right? But here we don't have much to worry about. We've got a number. We've got 65 degrees. So I'm going to put it right down there. See if that'll print out pretty well. 65 degrees. Let me put it out here. That's going to be 65 degrees right in there, okay? And over here, well, if it's supplementary, which we said it would be, you got to subtract from 180, right? From 180. So it should give us, in this angle, 115 degrees, all right? That would be inside there. There's your 115. I'll put it in there just for all you like that. Now, our little M up here, opposite angles, or you can look at, hey, these got to add up to 180. Either way you do it, you're going to have 65 degrees. That's the beauty of this. So we'll put 1 tick on that, 1 tick on that, and I'll put an arrow there for those of you who want me to be sure that we make sure that is going right in there, 65 degrees, all right? And our last angle, well, supplementary or opposite angles, however you want to look at them, 115 degrees. Once again, we'll double it. Those are congruent, but notice, any other pair you put, supplementary. Put our 115 right up here, and we'll draw an arrow right in there, okay? That's where it's going. That's the story, folks. That's it. So if you can remember how to set up with either 180 or, guess what? Set them equal to each other. Congruent. That's what happens when they're congruent. They have the same measurement. When they're supplementary, the measures are doing the add up to, 180 degrees. So let's take another quick look here. Another problem. A little bit lighter. Maybe this will be a little bit easier for us to put our stuff in there. Besides, I used a lot of words here, didn't I? It says, find the measures of the angles of a parallelogram. So that's nice. We've got a parallelogram. Here we go. If the measure of an obtuse angle is 4 times as large as an acute angle. Again, if you want to put those letters on there, go for it. How about it? A, B, C, D we'll put up here. And again, using our rules, this one should be pretty easy. There's a little bit of a catch. We don't know any of the angles, do we, folks? We do not know any of the angles, but you do have a clue. You do have a clue. It says the obtuse angle, which I'm going to look at here and say D is going to be obtuse, or B, either one, is 4 times as large as an acute angle. Let's define. X will be our acute angle measure. x degrees, all right? Our obtuse, well, so you say, you're going to use y? You don't need y on this. You could do x and y, but I think it's a little complicated. We know 4x will equal our obtuse angle measure. As you read, there you go. So let's put it into our picture. Put an x right here. We put a 4x right here. We put an x here and a 4x here. My goodness, there are lots of ways to figure this out. One way isn't, though, to say x equals x. That doesn't make any sense because it could be any number, correct? Exactly. And 4x doesn't make any sense either. Now, some of you are going out there, Ernie, think. Yeah, Ernie got to think. I'm going to. You could add all those up and get 360, couldn't you? Oh, yeah, 360 degrees in any quadrilateral. That's the sum. Or, oh, yeah, here we go. You could use our little notation about, consecutive interior angles of a parallelogram. Oh, consecutive angles of the parallelogram. They are inside. They're consecutive. They're on the same side of that line segment AD. Yada, yada, go, go, go. Got it. So let's do that. How about it? That one sounds even easier. Actually, they're about 6 of one, half a dozen of the other. Or in this case, we'll find out what x is, and we'll know for sure what it is. How about it? Equals to 180. That's one option. And for those of you who thought about the other one I had, we could add all of these. X plus 4x plus x plus 4x. We get 360. But if you'll notice, I used half of them. I used half of what we have here. See, half 4x plus 4x. And here I've got all that stuff. Taking half of, well, half of 360 is 180. So you'll get the same answer, get the same value. Let's work it both ways. We got 5x, wow, equaling to 180. Do some quick division, and it does come out even very nicely. How about it? We get 36. And by the way, remember, that's a 1 in front of that x. So some of you are going like, where do you get 5x? I only see a 4. Remember, 4 plus 1 gives you 5. Now out here, remember there's little 1s here also, for those of you who like a little crutch. That gives us, wow, 10 of those all together. Just x, not x squared or x fourth or anything like that, just x, equaling to 360. Now let's clean it up. Well, goodness sakes, it's still 36, isn't it? So that, folks, is our small angle. Well, here we go. 36 right here. 36 right here. Degrees. Awesome. Now, what about 4 times 36? Well, think that in your head. Use a calculator if you need to, but let's go ahead and think in our head. I believe it's going to be 2 times 36 is 72. Let's just take 72 times 2. We're at 144. And beauty of it all. Yes, there is some beauty here. Put a little degree marker on there, Roberts. Yeah, there you go. And these two add up to, well, my goodness, yes, they add up to 180. These two, 180 is great, all right? And everything inside there adds up to 360. So the angles are 36, 2 of them are 36, and 2 of them are 144. There's your story for the angles. So you see, parallelograms give us extra clues. They give us some things that we work with. Congruence. We also work with the supplementary pairs. So we're going to look at some more of our stuff today, all right? So let's see where we're going on our next problem. Got a sweet-looking problem here that involves, well, let's see. It says, find the measures of the angles. Man, that seems to be the story today, isn't it? It's, well, angles are relative. How do you know they're relative? Because it depends on, are they opposite angles or are they consecutive angles inside that parallelogram, all right? This time, let's see where we have gone, all right? We have measure angle A. I don't know if we can find all the measures. Yeah, I bet we can. I bet we can find. If we know one angle, right, we're going to be able to find all of them. Some of you are going, Ernie, there's no clue to those other 2 angles. There's nothing about A and Y. Oh, yes, there is. There's plenty of room to get out of this problem. So let's take a look at this. X and Z. First of all, let's mark them. They are the big ones. They are opposite angles of the parallelogram, and we know, you know, I know, we all know, right? They are congruent. So we're going to set the measure of angle X equal to the measure of angle Z. Now that's sweet, okay? Now, let's replace X and Z with these P expressions, all right? So since I put x here on the left, we'll go ahead and put the 4p minus 20 right underneath it. There we go. On the right side, we've got 2p plus our 60. Life is good. Now remember, they're going to be equal to each other. So we're looking for a p-value that will say, hey, we have the same amount here. All right? So let's play it through. Let's play it through. What I need to do, I'm going to move the 2p right on over there. Subtract it from the right. We got to subtract it from the left. Oh, haven't used that phrase in a long time on this show. How about it? Subtraction property of equality. We got it. All right. Let's see. It gives me 2p on the left minus 20. Over here on the right, 60. You know, when I focus on parallelograms, sometimes I forget about the other p word, the properties. All right. Now, let's add 20 to both sides here. And you know what? That's going to ride right over here. We're going to say we have 2p. Y'all got it? Equals to 80. Now, that was the addition property of equality when we added 20 to both sides. So I'm looking at p equal to 40. That's nice. You say, well, why is it so nice? Well, I think it's going to be nice. I hope it's going to be nice. Let's see, do we get the same value for these angles? Because when I plug a 40 in here, I've got 40 times 4. Da-da-da-da. Yeah, I believe it works, doesn't it? Y'all with me? 160 minus 20, 140. So angle X, did y'all hear what I just did? Oh, just substitute both sides. You're going to get 140 degrees right up there. And guess what? If you take 2 times 40, you get 80, right? Add 60 to it. Da-da-da-da. 140. They're supposed to be equal, right? I wouldn't lie. I wouldn't lie. Exactly. So 140 degrees. There you go. There you go. Find the measures of the angles. It means I've got to find 2 more, right? Irregardless of p here, these 2 angles are going to have to work because they're consecutive here, right? You could say, well, you know, you could add them all up and get 360. That's one option. But let's just use the opposite. The opposite? No, we've already got the opposite angles, right? We need the consecutive angles going here. And we know they add up to what? 180 degrees. So put a 40. That's a 40 there. Put a 40 right here. My goodness, there's going to be a 40 going on there. And you see what you've got. You've got opposite angles congruent. You have 360. You also have satisfied your p-value. My goodness, life is good. Again, it only works. Notice here we have our little parallelogram. And notice how we said it. X, Y, Z, A. Always make sure your picture matches your words there, all right? Important, very important. All right, so that's where we're going. That's where we're going. All about the angles. Great stuff, isn't it? Some of you are going like, oh my gosh, what else are you going to get into today? Let's look real quickly here. Sum up what we've done here. A little summary of parallelograms. We have opposite sides congruent, opposite angles are congruent, and what else do we get about consecutive angles? They are supplementary, supplementary. So let's go to our next slide here and see if we got one problem for the road here, all right? One problem to finish us off, and I think we do. Right here we go. Oh, this looks good. Let's put it, let's work it, let's go with it, all right? E, F, G, H, life is good. You know what I like to do when you got a picture? Put information on it, all right? And this one, it really is kind of nice because we got a 60 right here, 60 degrees. We also have angle E down here in the corner where 3x minus 12 degrees, all right? And then you've got, oh, wait a minute, they just changed horses with us. We said x plus 5 for GF. It's going to be a little thought here. And then we got GH up here at, how about it, 2x minus 3. Now my thought is there's no relationship between 2x minus 3 and x plus 5. They're consecutive sides. There's no equals or supplementaries or anything there. However, here is where our magic happens. This is where the magic happens. So let's take a look at it. We're going to look for a perimeter. So we got a lot to work here. Let's say 3x minus 12 equals to 60. Opposite angles, parallelogram, congruent. Move that 12 over. Add 12 real quickly here. I understand we're running on time, so folks, hang with me. Work away. Some of you are probably ahead of me. And then divide by 3, I'm getting 24 for the value of x. All right, so we got 24. And real quick check, yes, that gives us 60 on both of these angles. Now the question is finding perimeter. So let's put in 24. Right there we go. That's going to give us 29. That's 24 plus 5 gives us 29. Woo, punch it in up here. 2 times 24, how about it? 48. 8 minus 5, we're going to get 45. Wow. All right, so here's where we go. Perimeter, add all 4 sides. We got a 29 over here, by the way, because opposite sides are congruent. And down here, we've got 45. Pushing it together, I'm going to count 2 45s, which gives us 90. These are going to give us 58. So I'm going to take 90 plus 58, and my friends, I'm getting 148. That would be meters, feet, what have you, whatever units we have going here. But we used our x to help us go from degrees to segments. Woo, that's pretty cool. And that's the kind of ACT question you might see out there. Hey, thanks for tuning in this afternoon. We're going to be back again with more parallelograms. We will see you the next time.